Lesson 2.2 talks about translations. When you translate a tile, you slide it from one place to another. When the tiles cover the floor with no empty spaces, the collection of the tiles is called a tessellation. So translate is simply a slide. The way that I connect the two is if I were to write the word translate, it has an SL in it, which would help remind me of the SL in slide. And basically you're taking a shape and you're sliding it to a new location. On the next slide, it tells you to look at the rectangle below and list the coordinates that are there. So when I look at the coordinates, coordinate A would be -5, 1, 2, 3, 4, 5. Coordinate B would be 2, 5. C would be -5, 1. And D would be 2, 1. So we've got our coordinates listed there. Double checking on the next slide, you notice that we had -5, 5, 2, 5, -5, 1, and 2, 1. So now the directions tell us to move each vertex. A vertex is a point or a corner of the rectangle. So every single one we have to move 3 units right and 4 units up. So I'm going to start with point A. I'm going to zoom in a little bit more. 3 units right, 4 units up. So with point A, I have to move it 1, 2, 3 units right and 1, 2, 3, 4 units up. I'm going to label my new point as A prime. This means this is the first copy of my original. So when I moved A 3 spaces over, 4 spaces up, this is the new location. I'm going to do the same for B. 3 spaces right, 1, 2, 3, 4 spaces up. 1, 2, 3, 4. This is going to be B prime. I'll move C, 3 to the right and 4 up. That would be C prime. And finally D. 1, 2, 3, 4. Now when I move my vertices, the shape should remain the same. And if you notice, my original rectangle was 1, 2, 3, it was a 4 by 1, 2, 3, 4, 5, 6, 7. It was a 4 by 7 rectangle. And with my new shape, it's a 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7. So the shape has remained the same. I just translated it or slid it to a new location. So now we want to record our vertices, our new vertices. So with A, we have -2, 9. With B, we have 5, 9. With C, we have -2, 5. And with D, we have 5, 5. The one thing that I want to show you is that if I look here, remember we moved 3 to the right and 4 units up. So look at this. If I moved on the number line 3 units to the right from -5, that would bring me to -2, moving 3 to the right. And if I moved 4 units up from 5, 4 units up would take me to 9. And that same thing happens every time. I went 3 to the right and 4 units up. 3 to the right, 4 units up. 3 to the right, and 4 units up. When I'm talking left and right, that's my x coordinate because the x-axis runs from left to right. When I'm talking up and down, that's my y-axis because my y-axis, if we look here, runs up and down. A translation is a type of transformation, and a transformation is when a figure changes into another figure. The new figure is called the image. So a translation is a transformation in which a figure slides but does not turn and does not flip. Every point on the figure has moved the same distance. So here was my original, moved to here. This one moved to here, and those were the same distances that they have been moved. When we get to the next part, it says, tell whether the blue figure is a translation of the red, meaning did we only slide the figure to a new location? No flips, no turns, none of that. So when I look here, and I match up my pieces, could we consider this a translation? Yes. Okay. When I look at B, if I were to slide this figure, if I were to move it from one location to another, it would still be upright like this. So since this one had a turn, this one would not be a translation. Okay, so on these next three, we have to tell whether the figure is a translation. And when I look at the first one, you'll notice that the original shape is much smaller than the second shape. So that means our shape had changed in some way or another. So it wasn't just slid, it was slid and then enlarged. So this one would not be a translation. The next one, no matter how I move the red figure, this point is going to be in the upper left-hand corner, and if I kind of move up, that's not what's happening with this one. This one actually got flipped, so this one would not. But on the next one, if we look at the distances between the points, all we did was slide it, so then this one would be a translation. Okay. So what we discussed before was the translations on the coordinate plane. We actually had plotted those points of the rectangle, and we talked about how we got from point A to point B. It says to translate a figure A units horizontally and B units vertically in a coordinate plane, you add A to the x coordinates, and that's when I was saying the left and right, and you add B to the y coordinates. So, for example, in this original, we'll call the red one the original. When I look at my x-axis, that's left and right. I had to move 1, 2, 3, 4 units to line up with my new A. So I moved 4 units to the right. And since I moved to the right, it's going to be positive, because on a number line, when we move to the right, we have those positive numbers. Okay? Now with our y, that's the up and down, we actually had to go down 1, 2, 3 spaces to get to that new A. So we represent that with a -3. So if we go to the right, it's positive. Left, it's negative. Up, it's positive. Down, it's negative, or minus, however you want to look at that. Okay? The next slide kind of summarizes what translations are. The description or the rule for a translation is that each point of the figure must be moved the same distance and in the same direction. If we look over here, this is telling us what to do. So if our original points were x and y, this one says nothing's happening to our x because it just stays x, which means our x would stay the same, our x would stay the same, and our x would stay the same. But with our y, we're taking our y, whatever it was, and we're moving it down 3 spaces, or taking away 3 from what our y was. So if I have this 3, I subtract 3, it should be 2 with 0. If I do 1 minus 3, it should be a -2. If I do 2 minus 3, it should be a negative 1. So this would be A prime, B prime, and C prime. So then I can plot the points. 2, 0 would be A prime. 3, negative 2 would be B prime. And 1, negative 1 would be C prime. And I should notice that these shapes, these two triangles, are the same, and that every single one should have been moved down 1, 2, 3 spaces. 1, 2, 3 spaces, 1, 2, 3 spaces. So they all were moved in the same direction and the same amount of distance. Now on the next one, you'll notice that it tells us that we have something happening to our x and something happening to our y. So with our x value, we have to add 4, and with our y value, we have to add 2. So negative 5 plus 4 would give us negative 1. Negative 3 plus 2 would give us negative 1. Again, we're adding 4 to our x's, and we're adding 2 to our y's. So negative 2 plus 4 would give us 2. Negative 3 plus 2 would give us negative 1. Negative 2 plus 4 would give us 2. Negative 5 plus 2 would give us negative 3. Negative 5 plus 4 would be negative 1. Negative 5 plus 2 would be negative 3. So we would have M prime, A prime, T prime, and H prime. So then we could go ahead and we could plot our points. We have negative 1, negative 1. Make sure you put M prime. We have 2, negative 1. There is A prime. We have 2, negative 3, which is T prime. And we have negative 1, negative 3, which is H prime. And then you want to connect your points to show that you have the exact same shape. The pre-image and the image, that just means your original rectangle or shape and then your new rectangle or new shape are always going to be congruent. The corresponding angles, if we look at our rectangle, they were all 90 degrees on both of them. The corresponding angles will be congruent, and the corresponding sides will also be congruent and parallel to the originals. Here were a couple practice problems. You want to make sure that you're reading the directions that say graph and label the pre-image and image. On this slide, we're first going to plot our original points and label A, B, and C. So if I zoom in, I have to plot negative 1, negative 3, which is going to be right here, and I call that A. I then plot 2, positive 1, I'm going to call that B. And lastly, negative 2, negative 2 is C, and I'm going to go ahead and plot that. From here, it tells us that we need to move our x 2 to the right. So we're going to add 2 to our x's. And we're going to subtract 3 from our y's. When we do that, negative 1 plus 2 is positive 1. Negative 3 minus 3 is negative 6. 2 plus 2 gives us 4. 1 minus 3 gives us negative 2. Negative 2 plus 2 gives us 0. And negative 2 minus 3 gives us negative 5. So I'm going to label these A prime, B prime, and C prime, and then go ahead and plot them. So we have 1, negative 1, 2, 3, 4, 5, 6. And that was A prime. We have 4, 1, 2, 3, 4, negative 2, and that's B prime. And then we have 0, negative 1, 2, 3, 4, 5. and that is C prime. So I'll connect my points, and what you'll notice is these two triangles are exactly the same. We moved 2 to the right and 3 down. And if I check from B to B prime, I move 2 to the right and 3 down. From C to C prime, I move 2 to the right and 3 down. And from A to A prime, I move 2 to the right and 3 down. On the next part, we only want to change our x, so our y is going to stay the same. So we have our y remaining the same, and with our x, we're going to subtract 6, which means we're moving to the left. 2 minus 6 gives us negative 4, 2 minus 6 gives us negative 4, and 4 minus 6 gives us negative 2. I'm going to label these E prime, F prime, and G prime. I'm going to first go ahead and put my first points in, and I'll put those in blue. So we have 2, 1, 2, 3, 4, labeled E. We have 2, 1, labeled F, and we have 4, 1, 2, 3, 4, 1, 2, 3, 4, labeled G. So we have our first triangle. When I then go and do our next triangle, I'll do those in red. We have negative 4, negative 1, 2, 3, 4, 1, 2, 3, 4, and that's E prime. We have negative 4, 1 as F prime, and we have negative 2, 4 as G prime. And when I look at my two shapes, they look exactly the same, and you'll notice that all we did was move 1, 2, 3, 4, 5, 6 units to the left. Every single point was moved the same. Here it says translate the red triangle 3 units right and 3 units down. What are the coordinates of the new image? So when I go to the original image in red, A is negative 2, 1, B is 2, 5, and C is 1, 2. When I go to A prime, I'm at 1, negative 2. For B prime, I'm at 5, 2. And at C prime, I'm at 4, negative 1. So what we want to identify is what did we do to our x, and what did we do to our y. So what's happening to each? Okay, let me erase this and I'll put a comma in there. Okay, so our x, like how did we get from negative 2 to 1? How did we get from 2 to 5? And how did we get from 1 to 4? You'll notice that in every single case we added 3 to our x. Now for our y's, you'll notice we went from 2 to negative 1, 5 to 2, and 1 to negative 2. In every case we subtracted 3 from every y. On the next one, it says draw the figure and its image after a translation of 4 units left and 6 units up. Okay, if I'm moving 4 units left, that means I'm taking my x value and I'm subtracting 4. I'm subtracting because I'm moving in the left direction towards the negatives. For my y's, I'm going up, so I have to signify that with plus 6. So now I can go through and I can subtract my 4 from every single x value, and I can add 6 to every single y value. 1 minus 4 is negative 3. Negative 2 plus 6 is 4. 3 minus 4 is negative 1. Negative 2 plus 6 is 4. 3 minus 4 is negative 1. Negative 6 plus 6 is 0. 1 minus 4 is negative 3, negative 6 plus 6 is 0. So now I can go plot my points at negative 3, 1, 2, 3, 4. That would be A prime. Negative 1, 4 would be B prime. Negative 1, 0 would be C prime, and negative 3, 0 would be D prime. So we have our new shape. And you'll notice, if I were to check to get from A to A prime, I go to the left 1, 2, 3, 4, and then I go up 2, 3, 4, 5, 6, exactly what the directions had told us to do. On the next slide, it says that we have the triangle here. We want to translate 1 unit left and 2 units up. So what's going to happen is we could list our x's and our y's and then talk about how we can go 1 unit left and 2 units up. But we can also just look at our shape. With A, let me zoom in. If I go 1 unit left and 2 units up, that puts my A prime, 1 unit left, 2 units, right here. So I went 1 to the left and 2 up, A prime. With C, 1 to the left and 2 up. And with B, 1 to the left and 2 up. I can now connect my points, and you'll notice that I have the same shape. So sometimes it's easier to use the coordinate points, usually if they're already listed, but sometimes it's just easier to take the shape and move it yourself. Okay, on the next one it says the vertices of a triangle are -2, -2, 0, 2, and 3, 0. Determine the coordinates of the figure and its image after a translation of 1 unit left and 2 units up, which means we're going to take our x and we're going to the left 1, we're going to take our y and we're going to go up 2. So we can put that little note in here. All of our x's are going down 1, all of our y's are going up 2. So our new coordinates would be -3, 0, -1, 4, 2, 2. Okay. If you have any questions about this lesson, you can go ahead and email me. My email is Hughes, Hughes, @milton.k12.wi.us. And please make sure that when you type in my name, make sure that it says Ashley Hughes, because if it gets sent to my old email, I will not get it.